Okay, so when we talk about HBASE is a column-oriented database, right? So now now the question is, what is column-oriented and what is row-oriented, right? So in traditional databases or normal SQL, how data was stored? Data was stored like this. So you have a table. Let's say the same table which is represented on the left-hand side. So ideally, what you should be having into the table, you will be having student ID, and then name, then age, then branch name, and then GPA in this way, right? And you will be having 100 here, RAM here, 18, CSE, and 7.9. Like this is how traditional or SQL data looks like, right? You have, and now when you want to go, when I run a query, select star from, let's say this table is T1, where SID is equal to 100. Then which row will come as output? This row. And either I want one particular column or two columns, there will be full row need to be scanned, right? Let's say even instead of star, I want to go for age, select age. Still it need to go from here to here to here, and then it will give 18 here, right? So what is the drawback of traditional SQL systems is that we need to go, they stored row by rows. So inside the database, let's say it is 101, it is Monica, age is let's say 19, CSE, and 8.5, right? Anything. So in traditional databases, how it is stored, the first row will be stored like this: 100, some delimiter, RAM, 18, CSE, 7.9, like this, and then maybe some other delimiter, and then next row: 101, Mon, 19, CSE, and 8.5. And the rows are stored in sequentially, right? This is how the rows are stored, right? So this is good, right? This database is good if we want to select the full row. If we want to select the full row, this data is pretty good for us, right? But if we want to select only few columns, let's say I only go for 19, I only go for age. So how the SQL databases might be working, that it will go from here, it will pick 18, it will again go here, it will pick 19, it will go further, it will pick another age, and it will return the age, right? So ideally, what people thought about, that rather than if we put all the columns together, right? So let's put something like this. So if we put all the age column together into the storage format, see, this table and this table might be looking similar to you guys. This table and this table might be looking similar. The only difference is that these particular blocks are stored in separate physical files behind the scene, right? So let's say if I'm only searching name and age together, if most of my select queries are like this: select name, age from students. So what makes sense, that rather than I store these two columns in separate lines like this, can I store them together somewhere, so that if I need them frequently, let me hit that particular block onto the physical storage and bring that out, right? And this is where the column storage comes in picture, right? So what column storage says, that rather than storing data as a row format, let's store data in the column format, right? So what column format means, that let's first divide the data into column families. Column families means what? Column families mean, for example, in case of the student, we have two column families. One column family is related to student, and the other column family is related to branch, right? So in the first column family, what are the cells or what are the columns? The columns are name and age. In the branch, we have two more columns, B name, branch name, and GPA. One more thing, the primary key of SQL database in row, this is into row format database, right? Row format database. Now this primary key will be called as row key. Row key in columnar database, call database, right? So let me have the mapping here. So primary key converted to row key, so that you guys can make sense. The first thing. The second thing is columns will be columns only, like columns will be columns. But the third thing with new things came in picture is column family. Call family. This column family consists of these particular columns. Like group of columns forms the column family. Okay, in this case, student is one column family in which we have two columns, name and age, right? In SQL database, one row we call as row, right? And here also we'll call it row, and one cell we call it cell. So here also we are calling them cells. Makes sense, right? Any doubts till now? So this is how the column based family, like the column oriented database will look like. So behind the scene, you have column family and then columns. Inside columns, you have cells and you have row key. Okay, now let's talk about HBASE. So HBASE is again a column oriented database, right? So HBASE is a column oriented database. So behind the scene, the data will stored like this only, right? So we have column family, row key, cells, right? Now what I written here, that each row will have same column family and column can have different number of columns. Okay. One most important thing, right? So when we talk about, so let's say we have this database, right? We have this database and we have one more row which is 104, right? And this particular person has name, let's say Monica, right? And let's say by mistake her age is missing. So for this particular 104 row or 104th row ID, we can have CSC here and let's say 9.5 some pointer here. So what I'm trying to say here, that for each row we have same number of column families. We have same number of column families, but the number of columns can be different. So for 104, how many columns we have? 3 columns. But how many columns we have? 2 column families, right? So the column families will be same for each row, but inside each column family we can have different number of columns. Okay, and that's where yesterday's example came in picture, right? And that's where, so once we store this data, right, so this space is never used, right? So either in traditional databases, even we are not using this space will be allocated for null. But when we talk about column oriented database, this space was not even touched because we don't want it. So it will be like this. So in this particular column family, we have only one column, that's name. In the branch column family, we have 2 columns, that is branch name and GPA. Okay, so each row will have same number of column family, right? So let's say we have 100 rows. All 100 rows will have 2 column family, but all these 100 rows might have different number of columns in each row, right? Now the question arises, let's say if we insert one more row here, right? If Ram changes his branch from CSE to, let's say, mechanical, right? So ideally what we should have one more row here, same age will be same, but the branch will be ME now, and it will be, let's say, 8.5. It's the same 7.9. Okay, it will be same 7.9. So in this case, how we are making sure that versioning is maintained? Now let's say, and if I want to select 100 row ID, then which row will it should return me? It should return me this row, right? So what it is doing behind the scene, it is adding one more virtual column here, which is called timestamp. So let's say this timestamp is T1 and we updated this row as T2. So what HBASE do behind the scene, it will always pick the latest timestamp for each row ID. Making sense, right? So HBASE will always pick latest timestamp for each row ID. That's why whenever we say select won't work in HBASE, but I'm just giving an example. Select star from T1 where row ID is equal to 100. It will return this row. Okay. So let's cover one more topic. Yeah, this is the correct way. Okay. So now one more important thing is how data is stored. Let's say this is the correct example, right? So all the rows, all the row keys or row IDs will be stored in lexicographically sorted order. So what it means, they will be in ascending order, and lexicographically means if it is ABC, then it will be like, if it is A101, then C101. So it will be like, it will be stored into alphabetically increasing as well as numerically increasing, and we call it lexicographically. Okay, so the keys will be always stored in lexicographically or sorted order. I'll call it sorted order. Okay, and the versioning is maintained like this. I told you. So there will be multiple versions. For example, let's say this guy changed his personal column family residence phone column from this previous version to new version. Then what it will do, each cell has multiple version, typically represented by timestamp of when they are inserted into the table. Okay, so one most important thing, so the timestamp is maintained on cell label. Okay, so this is good till now. So what we came to know that in HBASE we have 4 things now. Row key first, second is column family, third is columns, what's going on, columns, and fourth is timestamp. Timestamp is basically used for versioning. Versioning means to store the previous data and to get the latest data. Row key is like primary key, and it is stored into sorted format, ascending order. Now the question arises, why HBASE need to store primary key or the row key in the sorted order, so that it can do some searching. It can do some binary search or n number of searching algorithm. It can optimize it, right? The question arises, why we need to go for column family, and why HBASE is a column oriented database? Because we have column families into it, and column family has columns into it, right? We have column families, and then we have columns into it, right? So why we need to have column families? Because we need to, ideally we will put those columns in column families which make sense together, which ideally will be searched together. Okay, because behind the scene these column families will be stored in a single file. Okay, so this is all about HBASE data model. Okay, now let's go to HBASE
Neelendra, I have a doubt, like
yeah,
is the primary key same as the row key? Are the functionality same, or how row key is different from primary key? Like what is the purpose?
So basically see, primary key, when we talk about primary key in traditional databases, right? So what ideally we do some indexing, so searching can be fast. Same thing HBASE implemented for row key as well. So row key cannot be duplicate, primary cannot be duplicate. They need to be unique, first thing, right? Row key is used for searching. When we search using row key, it usually HBASE usually use binary search behind the scene. In traditional databases, primary key has different indexing mechanism, so maybe binary, bitmap, or something. So yeah, so more or less same, but implementation might be different. Okay, so functionality is same. Okay, so let's go for, so you guys came to know that okay, we have row key. I'll write it here. So we have row key, column families, columns, and timestamp, right? These four things, we need to store it somewhere. This thing is pretty clear to you guys, no doubt enough, right? So now the question arises, how data, and I told you that column families will always go into same file. And the column families for each row will be same. Each row has same column family. We cannot change it. Columns can be different, okay? So now question arises, how this row key, column family, columns, timestamp stored behind the scene? How HBASE is working, right? What is the architecture, and which are the different components we have, right? So what is going on in HBASE? So in HBASE, the most important thing is region. So basically, all the data files, or whatever you want to call it, is stored in regions, right? Regions. So basically, what we can say simply, that this data, what we are talking about, this particular data, row key, column format, sorry, column family, column, timestamp, will be stored in regions. Or we can simply say that range of row keys will simply stored in regions, right? So let's say we have 10,000 row keys, right? 10,000 row keys. So either they can be stored into one region, or for partitioning, multi-threading, or whatever distributed computing purposes, we can store them into 4 regions. So, and again, I don't know how it is stored, but let's say 1 to 2500 go to region 1, 2500 1 to 5000 go to region 2. So there can be multiple regions, right? So region stored row keys and all the data. So when we go here, we have regions, right? So region stored all the data. Now, one more component is the region server, right? Region server. So region server, there can be multiple region server. Each region server will control the regions which are allocated to it. So region server has regions into it. Region has data into it, right? Now, till now, the things are clear, right? Now, the question arises, which region server has which region, and which region has which data, where this stored information is held, like where this information is being held. So there's something like Hive, we have metadata table here. Metadata table here, right? So this information is stored in metadata, right? Now, one more question arises. See, HBASE, we can see here that we have region server, we have regions, and then we have H master or HBASE master. So what H master will be doing? So we have RS here, RS here, RS means region server, and then inside this we have R1, R2, R3, R4, R5, R6, something like this. Like, and now let's say this RS is gone. So ideally, this load of these regions should be transferred to somewhere else, right? So ideally, what should be doing? There should be someone who is looking after it. That okay, which region is active, which region server is active, and number of things. So that thing is doing H master. So again, HBASE is a master slave architecture in which we have H master, region server, regions, and obviously this data. Till now, things are clear, right? Okay. And then in HBASE, the storage is HDFS. HBASE has not having its own storage. So it will be either using SDFS or maybe using some S3, maybe using some data lake, something else, but it is storing data somewhere. Okay, now coming to the Zookeeper. So what we know about Zookeeper? Zookeeper is for orchestration. Zookeeper is for orchestration. So this metadata table, right, what I'm talking about, so where, which region server is stored where, which region is stored where, which region has which key. So this metadata table is stored on some regions, maybe here. So what Zookeeper maintains that, okay, this metadata table is on which region server, on which region. Okay, so what, whenever client wants to, let's say client wants to talk to this particular region server for row 100, 1 to 2500, right? So client want to select 100th row. So what client will be doing, client will talk to the HMaster. HMaster will talk to Zookeeper. Zookeeper will give the master table. Then client will directly talk to the region server. So ideally, the client, this particular connection is minimal. So most of the time, client won't even need to talk to HMaster. So client can directly talk to Zookeeper. Zookeeper can tell the metadata location of the metadata table. Then client can go to those region servers. Okay. So till now things are clear, right? Obviously this is complicated, but I'm trying to make it very simple. Okay. Yeah, this is again a very good diagram I found from Edureka. So what I talk about the Zookeeper, to Zookeeper, everyone region servers, HMasters will always sense the heartbeat. Okay, to say that, okay, I'm active, and once somebody missed the region, let's say this region server missed the heartbeat, what Zookeeper will be doing? Zookeeper will inform the HMaster that, okay, this region server is gone, please distribute this particular load somewhere else. So HMaster will be doing the load balancing. HMaster, the primary responsibility is load balancing. Okay, and every component, region server, HMaster will be sending the heartbeat to Zookeeper every predefined interval, maybe 10 seconds. I'm not sure what the interval is. Okay, so I covered this thing. Data is divided in regions, right? Regions are managed by region server. Okay. So when we talk about region servers, right? Let's talk about region servers now. So it's something like this: region servers, regions, and then data, right? So this region server, this particular region server, ideally, in ideal world, it should sit on one data node. So this should not be distributed. So each region server should have one data node into it. Okay, so there is one-to-one mapping between data node and region server. Okay, I will cover this val and BC in 2 minutes. Each region server can manage multiple regions. I already explained it, that each region server can manage multiple regions. Okay. Okay, and one more thing which I already covered, that the regions can have column families. Like regions will have data is made up of column families, and these column families will be stored as separate files onto the database. Okay, and now let's come to one more thing. Okay, so this is pretty clear, right? Or do I need to cover in more details now? So we have, behind the scene, we have SDFS. SDFS is made up of data nodes. In 1 second, guys. In SDFS we have data nodes. So an HBASE won't be having its own storage, right? When we talk about storage, it will either use SDFS or S3 or data lake Gen 2 or something like this. So it will be storing something like this, right? So HBASE will always sit, in this case it is sitting on SDFS, right? So let's cover one more thing. So in SDFS we have data nodes, right? on this particular data nodes, let's say we have here, how many region server we have? 1, 2, 3. So in this case, we have DN1, DN2, and DN3, something like this. This particular region server will be sitting here. So RS, and this RS will have R and R, something like this. So what I'm telling you here, that each region server will be sitting on only on one data rate. So it cannot go like this, that okay, region server cannot sit between two data nodes. It cannot. Okay, so region server will have one-to-one mapping. This is good. Now let's say, as I told you that HBASE is meant for OLTP system. OLTP system means we can read and write on the real time, right? But since it is sitting over HDFS, how we are making sure that we are reading and writing on the real time? So it means there is some magic somewhere here. There is some magic somewhere here because HDFS doesn't support OLTP systems. Okay, so what these guys did, these guys developed some components just to make sure that we can read and write with minimum latency, right? So this is how that thing works. Okay, so now what we have here, each region will have something called mem store. Each region will have something called mem store. As the name suggests, this is in memory. Okay, each region will have mem store, and each mem store will be storing. There is one-to-one mapping between mem store and column family. So mem store is equal to column family. So let's say we have two column family, then we will have two mem store in that region server, right? And so when we write something into, let's say we insert some rows, right? We insert some rows into HBASE. What is going on behind the scene? There is something called WAL, WAL. So that's called write ahead log. So let's say whenever you're writing some data, whenever you're appending some data, putting, deleting, whatever, right? So you're writing some data or deleting some data, it first goes to WAL or wall, whatever you want to call it, right? And from that wall, it will go to mem store. It will go to mem store, and then finally it will go to H file. H file means, so it will first go to wall, then it will go to mem store, then it will create H file or HBASE files, and these H files will be stored on HDFS, right? So mem store is in memory, that's RAM. WAL is again HDFS. I will tell you why it is in HDFS, and the final storage is in HDFS. So this is how, so when you write the data, right? So when you're writing the data, you are just putting the data into the mem store and the WAL, right? So this is where you put the data, it will go to mem store, and then once some threshold, let's say we put some threshold on mem store that okay, when the data is like 1 GB, when the data becomes 1 GB, flush it to the HDFS and create one H file into it. We always keep this threshold higher so that we don't create multiple files into HDFS, right? So this is obviously, this is HDFS data node. So when you see WAL and H file are in memory, mem store, which is in memory, is stored as a key value pair, just like H file. So the structure of mem store and H file is almost same. It just is, this is in memory and this is in hard disk. Okay, so this is how the writing takes place, right? So now the question arises, how do we need to read the data? Okay, how do we need to read the data? So whenever we read the data, right? So there are two things, or there are three things. So first thing is, which is faster, reading from hard disk or reading from RAM? So obviously reading from RAM or memory is faster, right? So reading from mem store or something maybe in memory will be faster. So when we talk about reading, so for writing, we have mem store, we have WAL, and we have H file, correct? When we talk about reading, so we go to block cache. Now the question arises, what is block cache? So block cache is whenever you read some data, you're gonna put that data into block cache. And this is kind of FIFO, first in, first out, or least maybe implemented as LRU, which is least recently used. So the cache algorithm can be any. So let's say you pull the RAM, Monica and RAM information. So that information will be here. RAM and Monica information will be here. Okay. So let's say after 5 minutes, you again pull the information. It won't go to H file. So what we are planning to do and what HBASE is planning to do, it don't want to go here frequently. It don't want to go to HDFS frequently because HDFS is slower. It's not very fast, right? So it will go to block cache, right? Now, again, if the data is not here, then it will go to memstore. If data still is not there, then it will go to H file. So when you see here, the first priority for reading gonna be block cache, second is memstore, and the third priority is H file. Okay, so this is how reading and writing works. Okay, all memstore in region flush to the new H file. So what this thing is saying, that all memstores in one region will be flushed to a new H files on the disk. H file sorted list of keys and value. So what is there in H file? Sorted list of key value, right? What H file is, saves the last written sequence number so the system knows what was persisted so far. So this is the most important thing, right? So in H file, we have last written sequence number. So let's say we wrote till 100, and now system knows that, okay, when we need to write further, we will start a row key or something from 101. Okay, so this is how the whole structure is, right? Let me conclude it in 2 minutes. Okay, so now we have covered so many things. Let me quickly recap it, okay, from the architecture point of view. So first of all, we have region server. Inside region server, we will be having multiple regions, right? Inside regions, we will be having H files. Now I can say H files. H file is the final output when we write something, right? This region server will be mapped to one data node. There's one-to-one mapping. These regions will store physical H files, and there is something called H master, which will control this region server, right? There is something called meta, which is stored the metadata of this full mapping is stored in this meta table. This meta table will be stored on one of the region server, and there is something called Zookeeper, which keeps the location track of this table, right? And inside regions, inside region server, each region server, there is one-to-one mapping. When I talk about WAL, right? WAL. So for each region server, we have one wall or write ahead log and only one block cache. So it doesn't matter how many regions we have, number of wall and block cache will be number is equal to number of region servers. Okay. And okay, now when we talk about memstore, each insert will go to memstore first and then create the H file in HDFS, right? So one more thing. Okay, now this mapping is clear, right? So number of region server is equal to number of vals is equal to number of block cache. Okay, now let's come to memstore. So what memstore will do, when we write data, it will go to val first. From val, it will go to memstore, and from memstore, it will go to H file, and H file will be stored in HDFS. So here it will be HDFS, right? So now, what is the relations between column family and memo store? So I was trying to communicate this thing very clearly. Each column family is a separate file. Each column family is a separate file. It means to implement this, since data from mem store is going to H file, right? I made this clear, right? So it means, and one thing is clear, that each column family will store in one file. So it means there is one-to-one relation between column family and mem store in each region. So in each region, there can be multiple column families. So there can be multiple mem stores, right? So this is good. Block cache, and this is one-to-one ratio with region server, right? So any doubts? This is complicated, but I tried to cover in the most easiest way you can ever find on internet. So HBASE is a master-slave architecture. The master is called HMaster. The slaves are called region server. Inside region server, we have regions. Inside regions, we have data. The data is divided as a column-oriented database. In each data, we have row keys, right? And each region server can have multiple regions into it. Then the mapping of region server and regions is stored in a file called meta. Meta file is stored somewhere in one of the regions. The location of this meta file is stored in Zookeeper. Each component, whether it's HMaster, region server, will try to send heartbeat to the Zookeeper to tell Zookeeper that they're live. If the heartbeat is missed, then Zookeeper will tell the HMaster that okay, heartbeat is missed, and you need to do the load rebalancing through another region server. So Zookeeper is responsible for load balancing, right? So when we now coming to read and write anatomy. So when we want to write data, the data will be first written to wall or write ahead log. Then it will go to mem store, and from mem store we have some threshold set. And once the threshold is set, we will write a file called H file into HDFS. Okay, when we read the data, there's a new component called block cache. We will first go to block cache. If we find the data, we are good. Else we will go to mem store. If we find the data, we are good. Else we will go to H file. So last priority when we read the data to go to the HDFS, because that's the slowest thing. Okay, I think I have covered everything into HBASE architecture. Okay, so this is good. We have covered everything. Any doubts? I know it's very complicated. So any doubt, do let me ask. Okay, so now this is pretty good, right? So I'm stopping the recording for now. I'll cover the SDFS commands tomorrow, practical commands. How do we need to go for SDFS? How do we need to run commands? How do we need to use different create table, column family, how they looks together and all. I'll cover that in first 15-20 minutes, and then we'll go for maybe for Scala tomorrow. Okay. Any doubts right now?